So we're programming, and earlier tonight we were working on this effect for these mirror streaks, and it's a good start, but we're going to need to do a lot more. And I figured that part of doing a lot more and making it better and more continuous would be for this thing to have more of its own state for each of these streaks so that they can be coherent, and as the dude walks around, like, they won't radically change based on input length and stuff. And once you do that, then the idea that maybe we should drive it off this invisible particle system like I did is no longer really the best idea, because you're chaining the system to something else. And it's something that is not custom to what we need, and it's something that's not providing us that much utility. So what I'm thinking is just programming the custom mirror version of a particle system that handles these streaks and clipping them and so forth. And then we can go on and make them fancy as time goes on. If that makes sense to everybody. I don't know how long I'm going to do it. It's been a kind of long day, and I did have a nap today, but I could get tired at any minute. This is the 4th stream of the day, I think, if I'm counting correctly. Will the streaks eventually move? Probably a little bit. Like, I feel like they should go in the direction of travel, right? Maybe slowly, but they should sort of go from the guy toward the mirror and bounce off the mirror and go toward the reflection. And again, that'll be easier to do once we actually keep state for them, as opposed to like using a particle system. I mean, we could hack it with the current particle system, but it's a lot of hacking for maybe not great results, which is why I would rather do things custom. Do these streaks make you faster? Yes. Watch how fast I can go from the beginning to the end. Boom. Look at that. I was so fast. Boom. Boom. I'm the Flash. Boom. Boom. Watch how fast I can drown myself. Ah. They make you so fast. Maybe something closer to that thing happening in the water could work. My goal right now is not really to change the visuals at all, right? They're not supposed to be good yet. They're not supposed to be good yet. What they are merely supposed to be is they're merely supposed to be a new foundation on which to build things that will be good. I was thinking for a second. Come on. I got to think for a second sometimes. Yeah. So right now, what we already have is more plumbing than we had, really. And we're just going to do We're going to put more structure in for doing good things. So really, why is the particle system visible now? Haha. It always was visible. Okay. So if by the end of the stream I have something that looks exactly like this, well, it wouldn't even be exactly because I'm not going to use the particle system to drive it, but something that looks like this and not any better, but using a different structure, then I'm happy with that. I don't even know if we'll get there because frankly, I'm starting to feel tired already. It is 12:01 a.m. Okay. Okay, so here's where we draw these things. We're not going to use the particle source at all. We're going to make something else. And it's going to be called the mirror streaks. And we're going to start by making them just like the particles. For mirror.streak. Okay, and then instead of this, we'll call it it.position_t. We've got an it.color. That's great. Great. Okay. So what are these streaks? Well, they are not serialized. They're an array of mirror streak. What's a mirror streak? Well, it's a thing. It's got a position. It's got a length t. Let's call it length t instead of position t. No, beam. Let's call it beam position t. That's a float. We've got a size. It's a float. And, well, we've got things that a particle has. So we've got actually, no. Let's just say color is a vector 4. We've got an elapsed, which is a float, and a lifetime, which is a float. Okay. That might be enough. Because we're going to give everything the same texture right now. We're going to give them all the same fade in, fade out time. What does the underscore t? It just, you know, I generally use t as a shorthand. It just means it's a parameter between 0 and 1. Anytime I call something t, it's a parameter between 0 and 1. I don't remember where that convention started. I must have got it from somewhere. It doesn't always have to be clamped between 0 and 1. It could be unbounded, but like you would have 0 meaning the start point and 1 meaning the end point. And then if you could go beyond the end points, then maybe you could go beyond them. Any kind of mathy curve interpolation uses T for time. Yeah, that's probably where I got it. I probably got it from like spline stuff. No semicolon after struct declarations will fuck you up. You could put a semicolon there if you want. It won't do anything. You could put it there though. Yeah, parametric equations use T as the variable. Yep, that's where it comes from. Okay, so great. We need to update these mirror streaks, and we need to reset the mirror streaks and catch up on them when we need to. So let's go to post, undo, reevaluate. So when we undo, we're just going to restart the mirror streaks because, well, because the thing, you know, when you do an undo, the guy that it's attached to may have changed. And instead of animating it continuously, we're just like jumping through time. So restart and catch up streaks for that mirror. Let's just put that on one line. And then we need an update streaks that gets called in simulate. Oh, it's not called mirror, it's called it. Okay, so in let's put it in mirror aisles. We'll just put these things. We need an update streaks, and we need restart and catch up streaks. These are the things we need to define. And right now we're going to define them as empty and make sure we compile, which we probably don't. Get particle alpha. Ha ha. Ha ha. We're just gonna say that the particle color every frame gets written with the correct alpha. We can do that because this is a different system for a different purpose. Okay. So now what? We're going to run our program, and we're not going to have any mirror streaks because we didn't frickin' do anything. Ha ha. Okay. The update streaks should take a DT. And in simulate, no, DT. All right. Well, we want to spawn streaks. We'll do that after. For mirror dot streaks, update streak, mirror it DT. All right. Put these in file scope. Streak mirror streak DT is a float. That's going to do nothing. And spawn streaks is going to do nothing. See, this is great. You program and you do nothing. Ta-da! We're done. No, wait, we're not done. We're not done. Okay. The mirror needs a thing called DT streak spawn DT remainder. That's going to get 0 when we start and catch up. That on the mirror all right, so plus equals DT. Time per spawn is going to be what did we have? We had our particles per second set to like 3. Let's call it 0.3. While mirror.streak spawn DT remainder is greater than or equal to time per spawn. Okay. Now I have to remember how to do the thing, so we're going to decrement this. But also, when we simulate the particle, we're going to do some stuff. And then we want to simulate the particle for the part of the frame. Okay, so DT. Incomplete. Simulate the subframe amount that happened after the spawn when I am not tired and can think about it. Okay. Incomplete. That's fine. That would look like update streak, mirror streak, DT remaining. All right. array add mirror dot streaks comma streak. Okay. What does streak look like? Streak is a mirror streak. Is that what it's called? Yes. Random get 0 to 1. X, Y, and Z. Boom. Z. No. That. Well, so we're generating within a cube centered around the origin. In the mirror rendering code, we already project this to whatever axis to flatten the streaks out, so that's fine. Beam position T. Let's, instead of calling the 0 to 1, let's do that. Size is random, get within range, I don't know, O dot 001, 005, and O dot 02. I have no idea. We're going to make settings variables for all of these, but first, well, not all of, maybe not this yet, but T avoid is O dot 2. T avoid 1 minus T avoid. Okay, streak size. Streak dot lifetime is random get within range 4 and 6 seconds. Color 0 is vector 3, 1, 1, 1, 1, right? Color 1, or vector 4. Yellow would be red and green, and not that much blue. Let's say it's not super yellow. And then streak.color is lerp. Color 0, color 1. Random get 0 to 1. Okay. So we never unspawn a streak yet, so this will be a mess once it runs, which it does. Hey, look, there's streaks. They're showing up. They're not unshowing up. Okay, our T avoid is too big. You know, since we're going to clip streaks to the edges, let's make T avoid be 0 right now. We're just going to have more and more streaks forever. Forever. They never go away. Okay, let's make them go away. See how easy it is to make video games? You just do this, and then they're done. 4. Mirror. Oh, update streak. We already do the for loop. Well, streak dot elapsed plus equals dt. And then we do some other stuff. And here, we're going to update the streak if it dot elapsed is greater than or equal to it dot lifetime, remove it. All right. So now we unspawn streaks. See that? See that? Look how easy it is to program. Oh yeah, I'll switch to Unity now. Hold on. All right, man. So now let's make them fade in and out. Let's make them fade in and out. So we said that we're going to write into the color component every frame the new alpha value. Okay, so when we update a streak, so alpha is 1, and we're going to say streak color W equals alpha. But before we do that, we're going to say fade in time is 0.5, fade out time is 1.0. All right, so if streak.elapsed is less than fade in time, else if streak.elapsed is greater than streak.lifetime minus fade out time, we do this. If streak.elapsed is less than fade in time, alpha equals streak.elapsed divided by fade in time. We're going to make a setting for this, so we'll say denom is fade in time, if not denom equals 1.0. Alpha equals streak.elapsed divided by fade in time. Clamp alpha 0, 1 unnecessary. All right, same here. Divided by denom. All right, same thing. Denom is fade out time 1 minus streak dot lifetime minus streak dot elapsed. All right. So when we're equal to streak.elapsed, or when we're equal to streak.lifetime, this right-hand side is 0, so alpha is 1. When we're equal to streak.elapsed minus fade out time, oh wait, denom has to be streak.lifetime minus fade out time, right? Wait. No. Okay, when streak.elapsed is streak.lifetime minus fade out time, then this in parentheses is fade out time. Yeah, so this was right. That's right. Okay. Divided by denom. Wanted S64. What? 768. Fade in time. Alpha is 1.0, jerk. All right. Daemon equals 1.0 should be a language feature. Maybe. Oh, they're not really fading out correctly. It looks like they're fading in, but they are not fading out, Ghost Rider. Let's make that very small. Okay. What did I do wrong? Streak.lifetime minus fade out time. Oh. This is not 1 minus. This is not 1 minus. You are trying too hard, bro. Some people ask me how you get into the game industry. And I say that when you're doing the fade out on the mirror streaks and you're trying to make the alpha go to 0 at the end, don't try too hard. Don't put the 1 minus, and then you'll be successful in the game industry. Looks like our fade in is jacked now. Look at that, it's like flickering in. Maybe not. Dude, I don't know. It looks fine a lot of the time. And then sometimes it doesn't. Just like life. I think I'm drawing them generally thinner than they were before. So we're getting like weird aliasing things. Okay, so we're spawning these things and we're gonna go in that range. I should really make settings for these. Look how messed up it is. Frickin' fade in. What am I doing? This is what happens when I program when I'm tired. Alpha is streak.elapsed divided by denom. Looks right to me. It looks like it's 1.0 for like 1 frame. Oh, because we don't update streak before we render. Okay, when we spawn, see how this is commented out? We spawn guys and then we don't update them. So that's a disaster. There we go. There we go. That's great. Let's tune some things. Let's put some gameplay visuals. Mirror, streak, color 0 is a vector 4. Color 1 is a vector 4. Size 0 is a float. O.01. Size 1 is O.04. Fade in time. Is O.5 and fade out time is 1.0. Look at all these variables we have. We have 251 lines of variables. Oh yeah? No, we don't. We've got more than that. We've got 259 lines of variables. Whenever people ask me how to get in the game industry, I say you better have 259 lines of variables. I hope we do 4 vector colors. Okay. So okay. 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 Size, lifetime. Lifetime. We're just... Oh no, we did lifetime. Lifetime, size, color, fade in, fade out. We did it all. Except we didn't do it all. We didn't do it all. Now we did it all. Am I gonna miss the interns? Yeah, it's been good. It's been good having people do levels, man. I don't know what I'm gonna do now. I don't know what I'm gonna do now. Okay. Okay, so we forgot to do the catch up part. So for the catch up part, we're going to say update streaks mirror 5.0 seconds. So when we start the level, we already have some mirror streaks. Okay. Next, for our pièce de résistance. Okay, first we're going to check it in. I'm not sure what to do about this. I'm going to check at some point, but not now. when getting into the game industry, how many streaks do you prefer? Well, it's more about the quality of the streaks than the number of the streaks, honestly. How does it look when changing distance to mirror? It should be basically the same, because we haven't done anything for that. That's going to be like a whole extra situation, right? See, it's basically the same as it was. In fact, you know what? We're going to leave it here. Because I was going to maybe make a move, but the thing is, the smart way to make a move is just in world space rather than adjusting the T parameter, because that gives you control. And that means you want to pick the position in world space. And we haven't made that information hook up to this part yet, right? Like, yeah. But you know what? Let's do one fun thing. Let's do one fun thing, which is when you teleport, let's have the mirror glow and the streaks get really bright just for an instant. And then we'll do the position stuff later. Let's do it. For mirrors, well, we'll do this. Okay, and then let's add another variable. Mirror flash duration O.2. O.15. Okay. When we use the mirror, if it's successful, then we set this thing. We set this mirror flash elapse to 0. Okay, for every mirror that we successfully use, entities moved. Where did we get E from? Oh, from the Mirage. If mirage.reflector So we're going to set that elapsed time to 0. What is the reflector? I thought the reflector, oh, is it an entity ID? It's an entity ID, PID. If we find it, okay, it's not going to do anything yet. So, when we draw the streaks, we have an intensity factor. Alpha factor. This sounds like comic book heroes. Alpha factor. Alpha factor is this, right? Flash t is get mirror flash t of mirror, right? And then alpha factor is lerp we're lerping between these two values, and then we're multiplying that by the mirror lit t squared. Okay. Mirror streak alpha factor flash is 1.0. Okay, now get mirror flash t. That is going to be well, if mirror dot mirror flash elapsed is less than 0, continue. If mirror dot mirror t is gameplay visuals dot mirror flash duration, if no duration is 0.1, t is mirror dot mirror flash elapsed divided by duration, clamp t between 0 and 1, t equals 1 minus t times equals t. So we're going to square it so that it falls off quickly. Return t. So now in simulate, we need to advance this. We're just going to do it over here because else if, because we'd be doing essentially duplicate logic in both places, and else mirror flash elapse plus equals dt. If this is greater than or equal to duration, mirror flash elapsed is -1. We're resetting the timer. Otherwise, we are doing this. Right? Flash t is t. Okay. All right, after all that, maybe we have something. We've got, so let's call this mirror. All right, we going. All right. Yeah, man. I think it needs to be brighter, though. I think it needs to be brighter. Alpha factor flash 10. Yeah. That's programming 5. You can see it blooming out really. Our bloom is not very good. Let's go like 3. Now we got a stew going. So let's also make the face of the mirror there flash. In draw, it already, so I'll show you, before I even do this, the face of the mirror glows more or less, you know, when you walk in front of it on a little timer like that. So we're just going to add on this flash T. When it flashes, we're just going to add a little extra. So we're going to say mirror face flash extra brightness 5. I don't know. Let's call it mirror flash face extra brightness. Okay. And then when we draw the mirror, we set the entity parameters. Oh, we look for lit T. Effect color. mirror.lit t plus mirror gameplay visuals dot that times mirror dot flash t. All right. Boom. Okay, well, it's happening, but you barely see it. Like if you look at the darker, when you see something that's a little more blue in there, you can see it go white, but it's not very visual. So let's say 500. Still not very. We're basically saturating the max color. Now we're turning it negative. That's not better. Well, we could change the color. It's not very easy to do. It's in a shader. Well, we're just going to leave that, and we're going to say flash t has no visible effect. Need to pass it as a parameter to the shader so the shader can do something cool. That's fine. I didn't write the shader. Eric wrote the shader. We'll figure out something cool to do with it. Boom, 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 boom. All right. So next time we work on this, which maybe that'll be tomorrow, or maybe we'll feel like working on the compiler tomorrow. But next time we work on this, then we'll work on having the streaks be continuous as you move around and not get stretchy. But this is great. This is more than, you know, we got our gravy feature, which is the flash. More than I had expected to do today. And we did it in an hour. You got hired by Obsidian. Finally, you've been doing interviews for a while, right? Well, congrats. Have a good time. Flash a blood splatter on the mirror when you teleport. Yeah, baby. Not a lot of people want to hire a 19-year-old. Yeah. But see, once you have a job, as long as you don't get fired in the first 6 months for like gross negligence, then you're fine after that. Because, you know, Obsidian is a well-known, reputable game company. If you don't like it there and you want to go somewhere else, plenty of people would hire you once you have experience there. So you're good. You're good at this point. Unless you screw it up. Try as a 44-year-old who quits after the first triangle. Well, that's a bit harder. I mean, the 44-year-old isn't harder. Dude, I'm older than that. But quitting after the first triangle... I mean, at least you could get the first triangle. If you mean you actually get it on the screen, because a lot of people can't get one triangle on the screen. It is a lot harder than it should be to get one triangle on the screen. Let's put it that way. Did I know someone ripped off Painter and won Ludum Dare with it? Well, I know some guy ripped off Painter and made $400,000 on Steam with it. Do you mean Ludum Dare this year? Or Ludum Dare, or however you pronounce it? I hadn't heard that. Some time ago. Well, I hope somebody pointed them at the Painter prototype. Uh-oh, Insobot's spamming again. You got hired at Rockstar. Well, great. Glad you did. Let's see this. 90-second portraits. Yep. Well, you know, maybe they had that idea themselves. Hard to say. I mean, the actual good part of Painter, or the interesting part from a game design standpoint, was not the fact that you're just painting portraits, but or painting things, but that there were little AI routines that would judge your paintings, and the different judges had different things that they wanted to see, you know, and then you were trying to figure out what those were and like navigate this fictional gallery scene. That was like the interesting part of the game. And everybody I've seen who, well, the one previous program that I've seen that seemed to be influenced quite heavily by that prototype just bailed on that, on the interesting part. Yeah. That's what makes me annoyed. I'm not annoyed that somebody likely, I mean, anyone could have the idea themselves, but it sure looked like this other thing that I'm thinking of sort of copied. But they didn't copy the actual good part, so I don't know. I don't know, man. What's better for a career, writing and publishing a different open source framework, or learn and apply a modern technology stack? Neither of those sounds very good to me. I'm sorry. Everybody and their dog publishes open source libraries and frameworks. The trick is to make one that's actually good, which very few people know how to do. Apply modern technology stack? What does that mean? That doesn't mean anything. If you can build something coherent that works and demonstrates skill, then it doesn't matter if you did that with a modern technology stack or by hand. People will see that you built something interesting and they'll be like, oh, that's great, let's do that. The key is to build something interesting, right? The key is not release open source. The key is not use a technology stack. Those things are not relevant. Unless you want to get hired somewhere really dumb who doesn't know how to vet programmers. Which might be your goal, but probably wouldn't be happiest there. Why does the particle effect when switching position in the mirror only happen in one direction? I don't know what you mean, only happen in one. It's happening in both. See? It's happening in both. It's just a different effect, and one is bigger and lasts longer than the other, see? Let's slow it down less. Particle effect seems to show up late. Wait, why didn't it show up at all that time? I think it's getting confused by the time dilation. Wait. I think it's getting confused. Whoa, what? It didn't like happen at all. Okay, it's happening inconsistently. That might be a rendering bug or something, you know. See, right there it didn't happen either time. There it only happened, only one of them spawned in the source and 2 in the destination. There neither. There all of them. Okay, we're gonna have to debug that. Thank you for noticing. I hadn't noticed that. I'm not really sure what would cause this. It's going on the list. Debug, mirror, teleport, particles. Exclamation point. Why is beautiful water not applied to this level? Because it's not. This isn't a real level, and even if it were, it has a river in it, and the new water doesn't do rivers yet, but it will. It's game development. Not everything, you know, things have to get done. Not everything is magically done. If it was, we would release the game already. It doesn't happen exactly every other time, although it does seem to kind of happen every other time. So I wonder, I feel like it's some mistake involving, okay, I can almost exactly tell you what it is. We go and we destroy the old particle systems, maybe. I'm not sure, but maybe. Maybe not. But if we do, you know, it's possible that we're modifying the list of particles while we're iterating over that array in a parent scope, and things are getting confused. Like when you see something really weird like this, usually it's something like that. But we'll see. We'll see. Yes, we will have to fix that. But I don't know, you know, I kind of feel like maybe we'll do a compiler stream tomorrow. I don't know. Yeah, it's totally like, I mean, it's sort of doing it every other time, but then if I wait a while, see there we kind of got a half C, where we got a smoke on the bottom one, but no fire, and we got both on the top one. And that time we got fire, but it didn't last very long. That time we got full fire. We're going to have to look at that. The fact that it mostly happens every other time is suspicious, but it still isn't completely consistent. That's going to be a weird bug, man. Should just finish everything at once right now. Can't be that hard. Yeah, you're right. Can't be that hard. All right. What I'm going to finish now is finish going to bed. This was our 4th stream of the day. It was our 2nd short stream of the day. It was longer than our 3rd stream. We got things done. Maybe I'll even put that on YouTube because we got things done. Let's see if there's anyone. What are the odds that there's anyone at all programming something interesting this late? That doesn't look like programming. I don't know what that means. Curl development. Could do that. Curl hacker. Giveaway, no. If you need gimmicks for people to watch your stream, that's no good. Leland, we could do Leland. Could do game dev chill. Oh, Manifold Garden. Let's do that. Now, we haven't done Willy in a while. We got to do Willy. We just did Leland a few days ago. All right. Thanks everybody for coming by and watch this. This game that I'm about to raid you to is a really cool game and it's really interesting. And yeah, I'll see you all later.